11.2.2 says prove giving reasons that triangle LKN is similar to triangle KSN. So triangle LKN is equal or similar to triangle KSN. So I'll highlight these two triangles. We have triangle LKN. This will be LKN, and the other one, which is KSM. So KS, let me fix that. KSM. So something like that. This is just to help us visualize these two triangles and see what they have in common. So basically we're trying to find a couple of angles and maybe a side, but clearly on the side section we don't have enough information. So we're just going to be trying to prove that 3 of the angles, or at least 2 angles, are equal within these two triangles. The first one I'll say is N3 is equal to M3. So actually, before all of this, we have to state which two triangles we're working in. In this case, it's LKN and triangle KSM. In these two triangles, usually the position of the letters is an indication to which angles are equal. So L and K, you'll find that there's a relationship and somehow those angles are equal. K and S and N will correspond with M. If we start with N and M, we'll see that N3, since that's the angle, that's part of the blue triangle, is equals to M3, which is the angle in the other green triangle. And the reason that they are equal is because they're angles in the same segment. Remember, we've already proved that this is a cyclic quadrilateral, so even though it clearly doesn't look like one and it's not bounded by the circumference of a triangle, we can still use those properties of it being a cyclic quad. So we say angles in same segment. Then I'll say L1 and M2. So L1 and let's see, did I write this correctly? LKN, KSM. Okay, so L1 is equal to M2, right? This we know because L1 is here and M2 is over there. The reason they are equal is also because of angles in the same segment. And we know from alternating angles that M2 is equal to K2, so L1 is equals to K2. So do you see L and K correspond, N and M correspond, and this is alternating angles here from M2 to K2. And then once we've said this, proving 2 angles is enough. By this we know that the last pair of angles, which is K in the blue one, so this entire big K, we're just gonna call it NKL, this will be equal to MSK. And the reason being, these are the angles of a triangle. If 2 of them are equal, then the other pair have to be equal because they all have to add up to 180. So you can say therefore triangle LKN is similar to triangle KSM. Reason being angle, angle, angle. So that is proved, but in case you didn't get either one, or you didn't get the second angle, the L1 and M2, you could have used another pair of angles as well. So I'll give you the proof to prove that this angle for K is equals to that S. So K corresponds with S. We see that from there. So K is over here and S is over there. So how do we prove this? First of all, we can say that NKL, let me use the black, NKL will be equal to, or let me just use blue in another stronger font, since this is just additional. So NKL is equal to M1. The reason being exterior angle of a cyclic quad. Then we can say that M1 is equal to S2. So M1, as you see it here, is equals to S2. This is because of corresponding angles. And that would be the proof for NKL is equals to S2 or MSK. So that's how you prove that question.